when I started looking into this, I sort of thought, oh, operating systems, not that many. But then I realized operating systems come in many flavors. So there's a lot of them. So what is it? It's just a collection of programs managing all the other programs and applications on a computer, allowing us to interact with that hardware or all the things we need to do to complete our tasks. They have two primary components in general, the kernel and the shell. The kernel is where all the processing takes place. Think of that as the mathematical brain, so to speak. And the shell is where we can interact. What does it do? It manages the hardware and software, of course. It allows us to interact with either a GUI, graphical user interface, or CLI, the command line interface. And of course, we all know what a GUI is. We've been using it for years, and many of us remember in the past, we used the command line interface with text-based interface, but many still are with Linux and things like that. It manages memory for us. It manages our files for us, allows us to access and organize our data, put everything together in a hierarchy of storage so we can find it. It manages the processes by prioritizing and monitoring everything to make sure everything executes in the proper sequence. As we all know, computers need proper timing. So that's where that is taken care of. It looks at the startup or the boot up procedures, as we call it, to make sure the correct sequence is run. It has sections that deal with data security, the user interface, of course, and then hardware and software control by connecting everything that allows us to interact with it and everything to interact with each other. Where is it stored? Typically in persistent memory. That would be an internal disk drive most days, read-only memory. We all remember some externals, USB sticks, of course, memory cards, and the old floppy drives. Long time ago, punched paper tapes even. So what are the different types of operating systems? There's a variety of ways of categorizing operating systems. Batch. That is useful for tasks that are time consuming and operate on large files. Payroll processing systems, billing systems, scientific computations, things like that would be suited to a batch operating system. Time sharing. It's beneficial for multiple users in multiple locations. It reduces the idle time on the processor and allows for fast responses to each user. We all remember the old distributed processing systems where you had the giant computer in the basement and everybody had a dumb terminal sitting on their desk. So in this case, that CPU was serving many individual users, creating an illusion that you each were having direct access and you were the only ones on the system. Multics and Unix are two examples of a time-sharing system. Distributed, it provides fast data exchange and is resilient. The distributed connects to multiple machines via a shared network. I think we could look at the Tor network as something that might fit in that category. Each computer has its own memory and operating system, but communicates with everything else in the distributed system. It's used frequently in telecommunication networks, airline reservation system, things like that. And they appear transparent to the users controlling the communications. It ensures data consistency and it coordinates all those different computers that are connected. And of course, a network type operating system allows sharing of files and devices, printers, scanners, things like that. Handles stability pretty well on machines, has functions for remote access, common file management. It manages users. It can handle system maintenance. They also handle the authentication system, the communication protocols, handles resource sharing, and authorization on the network. Windows, Linux, and Mac OS fall into this category. And of course, you have real-time systems. These are used in areas such as traffic control, weapons control, medical imaging, because they can provide near immediate response to inputs. A mobile system is designed, of course, with mobility in mind. You're going to find that on smartphones, tablets. They're usually optimized for touch interfaces, power efficiency, camera integration, wireless connectivity, GPS. They're the ones that have made computing portable and accessible to us all. Interactive, they provide direct interactions between users and the system using keyboards, mice, touchscreens, and voice commands. As you'll see as we go along, many of these types of operating systems are crossovers with some of the more known operating systems that we're used to. They kind of fit into multiple categories. An embedded operating system is one that is kind of hard-coded in, if you will, automobiles, industrial equipment, smart appliances. The Internet of Things tends to fall into the embedded operating system category. You can update them, but they're not operating like we're used to with a disk drive and things like that. So, how many are there? First, let's take a quick look at a few of the common ones. Windows, of course, very popular with us today. It's probably, well, it is the most used system out there. And it's pre-installed on most PCs sold today. Mac OS is a Unix-based system. It's probably, and I'm sure it probably is, the second most used today, although I believe Linux is starting to climb up the ladder. iOS, it's Unix-based, and it's the mobile partner. Of course, we all know about the iPhone. Android phones are very popular. A similar Unix-like system based on Linux, and it comes pre-installed on the majority of smartphones not made by Apple. Chrome OS, I think we all have seen Chromebooks sold. That's what comes pre-installed on them. As I understand it, they're looking at a new system coming up soon, which will probably take over the Chrome OS. GNU Linux, it's a Unix-like system. It tends to be used on the embedded marketplace in servers, and it also is being used on desktops and some smartphones. Popular distributions, as it says here, Ubuntu, Debian, and of course we all know there's about 2,000 Linux, or who knows how many. FreeBSD, Unix-based. It's the most popular BSD system. BSD is Berkeley software distribution. It's where it came from. NetBSD is another variant of BSD. It's a general purpose OS that's used on many desktops, and it can run modern browsers and has a modern desktop environment. OpenBSD, it's a Unix, it's forked off of NetBSD, and again, it's a general purpose that can be used on the desktop. Dragonfly BSD, again, fork of FreeBSD, and it can be used on the desktop. Lumos, it's an open source fork of the Solaris 10 distributions out there, and it's targeted at the cloud, NAS systems, servers, and some desktops. You don't see it very much. Haiku, It's an alternative OS that is similar to the old BIOS system that died back in the early 2000s. ArcaOS is a legacy OS that's been around a while. It caters to users of OS2. We all remember the IBM attempts back in the day. Drawback is it's kind of stuck in a 32-bit world. RISC-OS, reduced instruction set computing. It's a legacy from way back in the 80s. It went open source in 2018. Apparently it's fairly popular in the United Kingdom, which I was unaware of. It's kind of a limited design. It just recently got a modern version of a web browser and apparently has been ported over to the Raspberry Pi. AmigaOS, everybody probably remembers the Amiga systems. And it was, at the time, impressive for home users, but it's drugged down, if you will, by limited hardware support, only handles 32-bit PowerPC, doesn't have a very good web browser, but it was still receiving updates as of 2022, and it's kind of still based on the old 2019 version of WebKit. MorphOS, it has very little hardware support, no support for anything above 2 gigabits of RAM, which wouldn't be very helpful. But it's relatively polished, and there's some argument that it might be the most modern of the Amiga-like operating systems. Aros. It's an open source fork, if you will, or implementation of the old Amiga OS, but it doesn't have very many developers, and it can run on x86 hardware still, and it has modern features that the other ones don't. One thing it has is 64-bit support. OpenVMS, a really old system dating back to the 70s. It's really only marketed towards the server market. The DEC Windows desktop environment that I remember seeing back in the 70s myself is still being developed and supported apparently. And the new owner is just recently ported it to the x86 environment. So it's really designed for the virtual machine environment. So, more ways to classify. You all thought we were done with how to classify them. So, an architecture class operating system is categorized by the underlying hardware that it's going to run on, or the architecture, 32-bit, 64-bit, ARM, so on. Source code is another way to categorize operating systems. And you sort of see a lot of open source and mainstream systems. They're kind of a hybrid, if you will. Processor power, that's another way to classify an operating system. What is it designed to run on? Lightweight systems for low power, embedded applications, things like that, or heavy duty, full featured systems, or even specialized scientific systems or graphic systems. So let's take a little jaunt down memory lane. You all remember MS-DOS. Nice little system, single user, lightweight, ran on very minimal hardware, and could load data in with the old floppy disk. And of course it handled printers, and if you had the right drivers, scanners, things like that. And it handled all the input and output your computer needed most of the time, and of course, did file management pretty well. Drawbacks: didn't allow multiple users, no graphical interface at the time unless you went third party. Multi-programming, it only had one process and RAM at a time. No memory protection like that we have in the modern times. And it had a lot of difficulty if it was asked to address more than 640 megabits of RAM. Of course, Windows. We all know what Windows is about. x86 and AMD hardware, of course. Multi-core processors. Comes preloaded on most things today, most computers. The user base is huge, so there's a large availability of programs and utilities. Backward compatible, which is considered a feature, but it also can be considered a drawback, because being backward compatible means it can't really streamline for the future yet. And it has pretty good plug and play detection for new hardware. Network sharing, of course, works most of the time. For those of you who use Windows on a network, know what I'm talking about. A drawback, of course, it can be expensive because it's proprietary, and most of the applications that people run on it are also proprietary and can be expensive. It uses a little bit higher computer resources than some of the lighter duty operating systems. It gets slower the more programs the user loads up to the point it can even hang up. And one of the biggest drawbacks, I think, to Windows is because it's such a large user base, I mean, the largest in the world, basically, that means that virus writers and people like that are going to attack it because it's the biggest target. And it becomes more vulnerable if the users are not keeping up to date with their security patches and running their antivirus. Linux, which is becoming much more popular these days, we all know where it came from. It's a free open source, and it can be redistributed under the new license. You can be portable and installed on all kinds of portable devices, multi-user, multitasking system. And Bash is the interpreter program, provides different levels of file structures. It's all hierarchical, and it's a decent file system. Linux provides security with good authentication features at the moment, and the community stays on top of threat detection quite well. Drawbacks: there's no standard edition of Linux, so new users might be a little confused. It can be difficult to find applications. It's not a super large market, and the developers out there are developing more and more programs. It's getting bigger, but that's still a drawback. And many applications, especially in the business world, were developed for Windows or Mac, and there may not have been ported to Linux. There might still be some hardware that's incompatible if the community hasn't written the drivers for it. And there's a lot of forums out there, but some of the newer users may not understand the language that's being used. They may have difficulty getting help from the community. Solaris, Sun OS. So the Spark processors that are still around, it's a very scalable operating system. It can handle large workloads and still provide good performance. And they've Still known for rarely crashing. Again, company or corporate-based type operations. It's got really solid security that I haven't dealt with it myself personally, but I understand that the security is rock solid. And it's a good testbed platform. You can develop new programs pretty quickly. It's expensive operating system because it's designed for the enterprise market. Updates are not free. It lacks a really good GUI. It's not very user-friendly. You got to work to learn it. And the hardware support, of course, is not very good because it's designed for a very specific small target. Symbian, we all remember this. It was discontinued back in 2014, but anybody that had a PDA might have had Symbian operating system. All the small cell phones we have today probably forked coming out of Symbian. That's kind of what got things started, if you will. And it had a really good multi-threading system, good device drivers in the market, and third-party software could be loaded on it. The interface was very user-friendly. Most of the software applications for Symbian are written in C++ or Symbian C++, and Symbian has their own software development kit. It can run applications that have been written in Python, Java, Ruby, .NET, Flashlight, making it pretty, at the time, pretty useful. And it was pretty efficient and stable, if you will. And it's just not as smooth and sensitive as some others. And it's a little bit more vulnerable to viruses, and it had lack of virtual memory. Android. Everybody knows about Android phones, of course. And we could all go down the Android and iOS rabbit hole talking about which one is better, but Android's open source. It is optimized for graphics, multimedia, of course, connectivity, multitasking. It's got a friendly user interface depending on which phone you buy. Of course, it's open to customization. Lots of applications are available for your phone. And there are a lot of developers creating apps for it. Doesn't consume a lot of power, and its performance is good because it's based on the ARM architecture. It's dependent on Java, which makes it somewhat more difficult for the coding community. And you have to be careful of apps running in the background when you think you've closed them because they will drain the battery. I've had that problem with mine. It does not like a lot of programs running in the background, slows down a little bit. They overheat sometimes. In particular, I've discovered when you have GPS active, that radio can heat the phone up quite a bit. And the security profiles of most apps, because anybody can write an Android app, a little bit more susceptible to data breaches. iOS, of course, everybody knows about iPhones, written in C++, C, Objective-C, Swift, and the nice thing about it, it's based on the Macintosh system, so it's familiar for the Mac users to just use their iPhone with no problem. Interface is good response. has a lot of default applications that are included with the phone. You can get apps from the Apple Store, of course, and they are generally of higher quality than some of the open source or open developed apps that run on the Android side, because Apple has a really clamped down system for developers. And developers are going to be using their software development kit. It's a lot safer in general than most other mobile operating systems, again, because of Apple's lockdown control, and they provide regular patches and updates. Closed source sometimes means it takes longer for the developers to come up with new apps or better apps. And the iOS applications themselves tend to take up a lot more memory than applications written in the other mobile platforms. You have fewer customization options on the iOS side. Third-party installations are extremely difficult unless you want to jailbreak it. And the graphics and animations it uses can cause battery drains, and actually some iPhones have reported heating issues also. FreeBSD, it was widely designed really for server systems, but you can use it as a desktop system. It's pretty robust and stable. It's more designed for performance. It works rapidly, has pretty good security. It's very flexible. There's a lot of software available for FreeBSD. It handles networking and is up to date, even up to IP version 6. And it's under the BSD license, again, the Berkeley software developer, which has been open sourced, if you will, so you can modify it as you see fit. Again, hardware support is not as good. It's pretty complex. Takes a while to learn. And there's a lot smaller community of developers than there is for things like Linux. Chrome, it's a pretty quick system. Chromebooks work pretty fast. Web-based apps, you don't need to install things on the machine itself. It's very tightly integrated with the Google services. It has automatic updates and very good security. Drawbacks: if you're offline, you pretty well can't do much. A little bit. Software for Chrome OS is not as large, again, mainly because you're using it online. But if you can get online and you have an application that runs in a browser like Chrome, then you can run it. And again, it's designed best for a Chromebook, which has been designed specifically for Chrome OS. And if you're a Chrome OS user already, you're probably familiar with everything. However, that kind of makes you dependent on Google. Mac, of course, this is the desktop version, and it's got a good graphical interface. It's integrated with all the Apple products, and it's got a lot of built-in applications that come when you buy the machine. Software quality, again, because Apple tightly controls the developer community, is pretty high quality. Price, usually higher than most other machines are going to be. Hardware compatibility, it's only going to run on specific hardware. It's not going to run on anything you build yourself.
On how to make a junk journal.
Proprietary software, many of the applications and software are only available in the App Store. And again, lack of customization. So, in conclusion, I think understanding the different operating systems and how they're categorized can help us when we're deciding what we're going to use and how we're going to use it. Not just at our home environment, but in a lot of cases, what you need for work. You can choose based on a lot of different factors. You can really kind of navigate the pluses and minuses of different systems. Nowadays, we've got people dual booting Windows and Linux, so they get the best of both worlds there. And each operating system helps us move forward in what we're doing in their technology. I think probably operating systems are going to continue to advance and get more sophisticated and more functional and more useful, and probably are going to enable more and more miniaturization as we go along. So that's it. I'm going to drop the share. So
thank
Jim,
you,
I'll
Dale.
throw it
We
back
should
to
be
you.
able to take questions for a couple minutes.
Sure, no problem.
Okay, any questions from anybody? Unmute yourself. Any questions?
Jolyn.
Yeah, hi. I'm from the Hilton Head Island Computer Club, and thank you. I have experience with most of them, or no, most of them. It was a terrific presentation. Thank you very, very much.
Thank you.
I don't have any questions. I just wanted to say thank you.
Hey, that's always welcome. Thank you. Any other questions?
Phil, if you unmute yourself. He's trying.
Yeah, there we go.
There we go.
Hi. This is an odd question maybe, but I wonder if you know of any history of why it's called an operating system?
You know, I didn't see anything. That's a good question. I hadn't thought of that. I guess because it operates the hardware, if you will.
Yeah,
You know,
I tend to just think it evolved as initially just a collection of programs that programmers stuck on early computers, and it was the system of programs that allowed operation
yeah.
and eventually became the operating system or environment. Could have been called the operating environment.
Yeah, I think you're right. I remember systems that loaded with paper tapes, and each task was a single, how many feet of paper tape just to run one task.
Quite a bit of history.
Yeah.
Thank you.
Any other questions? I think I have one question. Most people, I'm speaking for myself, I don't know if I represent most seniors, but we look at a device, we don't usually ask what the operating system is. We want an iPhone, we buy an iPhone. We want a Windows computer, we buy a Windows computer. How should your presentation making us aware of the drawbacks and pluses of the different operating systems? Do we really have a choice? Aren't we device driven?
I think to a large degree, you're correct. Like Drew has a question or comment.
Yes, Drew.
Yeah, the people often have over the years asked me about what operating system they should buy. And the first thing I always ask them is what software do they need to use? Because it really depends on what you need to do that will drive the operating system that you must run. Right now, people are accustomed to getting into their cars and using either Apple CarPlay or what they call Android Auto. And that is using the computer that's in your phone, not technology that's in the car. There's a new operating system called Android Automotive that they're starting to deploy in Europe. And it's a full Android operating system inside the car. And the only thing your phone has to do is provide Wi-Fi internet access for the car.
Yeah, that's an interesting fork, if you will, from everything. Phil.
Along those same lines, we're in the era of smart TVs, and it turns out there are 5 different operating systems in smart TVs, some of which many of us may have come across before, and some of which are proprietary. But when you buy a smart TV and go to try to help your neighbor with their smart TV, you may find it just doesn't work exactly the same way you expected. So here's a whole collection of other operating systems.
Oh yeah,
But
Sony and
every smart device needs an operating system.
yeah, Sony TVs and Samsung TVs and LG TVs, they all use different operating systems.
Vizio, a different one. In fact, that's a more proprietary operating system. Thank you
Yeah,
again.
I have a Vizio TV. I'm not a big fan. I wouldn't recommend them.
I have a similar feeling.
Okay, thank you, everyone. Any other questions for Dale? Going once? Going twice?
Oh,
Okay, Dale, thank you very, very much for your excellent presentation. Great detail, yes. We'll give you a silent applause. And we appreciate your time putting it together for us. And we're very thankful. Thank you all for attending, and sorry about the glitches getting started. And we're very sorry for that. We're going to address those issues soon with our board meeting next Monday. So if there's nothing else, we've passed on the announcements tonight because Huey was not available. But please check your monitor issue, your monthly monitor, and everything is in there. And check the website, thestug.org, and find out what's going on. Okay. All right. Thank you, everybody, for attending. Have a great 4th of July. Don't explode your fingers.